Hello, my name is Philip and welcome at the second tutorial from the series of tutorials focused on development on Algorand using Raspberry Pi. In part 1, we set up our Raspberry Pi and now we can continue with the next steps. The next steps cover a short introduction where we provide details on how to set up a Raspberry Pi as a node, and also we provide steps on how to install some useful development tools. These tools will be used in the upcoming tutorials. Finally, we summarize our learnings. So let's start with the introduction. In Algorand network, are nodes important during the consensus phase? It is important that more than 2/3 of nodes are honest. So in case you want to make the network more robust, join the network. Our node can be used for staking and participation in consensus and development. In this tutorial, we focus on the node staking and participation in the consensus algorithm. For those who are new to Algorand, we also provide a brief overview of the Algorand consensus mechanism. It is achieved in 2 steps, where in the first step a user is randomly selected to propose a block. The probability of being selected is proportional to the user's stake. The user assigns and propagates the proposed block to the entire network. In the second round, 1000 users are randomly selected and each of them has to verify the received block. This covers the cryptographic verification, but also verification of formalities, such as the balance of accounts involved in the block and other formalities regarding the block. Finally, they share their vote if they agree with the block being later on added to the chain or not, and as long as 2/3 agree, the block is added to the blockchain. To mention, the nodes are not known to others until the point in time when they share their decision about the proposed block. That way, the attacker doesn't know which nodes to target until it is too late, since the rest of the network already knows their response. The consensus algorithm is run among different users in the network. The users are represented by nodes. Algorand network differentiates 2 main types of nodes, relay and non-relay nodes. First, relay nodes are used to communicate with both non-relay and relay nodes, and are used to route the traffic to non-relay nodes. As a result, these nodes have to be powerful servers to handle the load. They also need to have a public IP and open certain ports for communication. In addition, these nodes also operate in an archival mode, which means that they store a history of all blocks on them, which requires certain space. Second, non-relay nodes communicate only with a single or more relay nodes. These nodes participate in the consensus and are also called therefore participation nodes. Relay nodes can technically participate also in the consensus, but it is not recommended. Non-relay nodes can use the ledger for operations such as retrieving data from it or proposing new transactions. Finally, they can choose to operate in an archival mode as well, but they don't have to. In case they don't, they only see a snapshot of last 1000 blocks. In case they need more history data, they need to communicate to the relay nodes which have the full history of the blockchain. These nodes rely on a variant of a gossip protocol, and the topology looks as follows, where we have the orange relay nodes, which are connected to the non-relay nodes. In case you are interested, have a look at reference 7 to see more about the gossip protocol of Algorand. So our choice is to configure non-relay, non-archival participation node, which we will introduce in the following steps. So without further ado, let's set up our Raspberry Pi as a node. In this tutorial part, we will have a look on different Algorand network options. We will install the required packages. We of course have to catch up on all of the blocks, so that way when we do some transactions, we basically see the latest changes. We will make a wallet and an account on our Raspberry. We will also get some algos, and later on we will create participation keys and mark our node as online. So, starting with the part of Algorand networks, which options are out there? So as we can see, we are currently in the part of the private networks, where basically we currently operate in an isolated development environment using any available protocol version. So this is basically the current version where we are. We actually don't even have the current configuration even installed, but we will basically be in that point until we join the available network. And looking at what type of networks do we have, so we have three options. We have betanet, testnet, and mainnet, where the main difference between betanet and testnet and mainnet is that the betanet is basically showing the future changes which will be later on merged to the mainnet and testnet. So it's basically mainly used for development, so we can see in case there are new changes introduced, and we already can start to play with them and test them on our system. And then we see the testnet and the mainnet is of course the working on the current branch and the current work what we have in the latest stable version. And mainnet is of course the main Algorand network where it's basically running, and it's the real deal in some sense. And then we have the testnet, which is a copy regarding the version and also some of the behavior regarding the number of nodes, which we basically can use for development and playing around and getting ourselves familiar with the Algorand network. Therefore, for our setup, we'll be using the testnet, to which we connect our Raspberry Pi, and we will set it up as a full node. So what are the required steps? So we already covered the first part, and next we want to install the required packages on the Raspberry, catch up on the blocks, make a wallet, withdraw some algos, and later on make the participation keys and mark our node as online. So let's have some fun and join the network. Before we start with the configuration, I just want to mention that these commands which we will be executing are valid for the other distributions. But of course, in case we, for example, want to use Windows, Mac, Debian-based distributions or Red Hat-based distributions, the command syntax will be slightly different. So Raspberry Pi belongs to the section address in case you later on want to go and have a look on the developer tutorials page. So just keep in mind that the commands can be one-to-one ported, and these are specific commands for our current session. And starting with the configuration, we first want to SSH to our Pi, and since we are already in our home directory, we want to create there also a directory called node, and we want to change the directory to be inside of the node. Within this directory, we download packages, which are basically the Algorand commands which can be used later on. So we can copy this command, which will basically download the update.ssh. We can also have a look what is in this update.ssh. So we see it's a really complex and quite lengthy bash script containing all other stuff. And before we execute it, we want to change the ownership of this file, so it's also possible to be executed. And as a first command, we execute the update.sh with the part I, which is basically mentioning that we want to run it in this directory, and we want to download it from the stable branch, and we basically want to copy addition this path. So starting with it. Great, and now see that we finished the script successfully. We can also have a look how it looks now the directory, and we see that a lot of additional tools were installed directly to this directory, and these tools will be later on used during setting up the node. Therefore, we also can use the Algorand recommended data export, where we basically specify the Algorand data having this path to the node. And we hit enter, and now when we want to check and do echo Algorand data, we see that it's pointing to this directory. A very important command which we'll be using frequently is the one called algot. So in case we want to install this command system-wide, we can use it as a sudo system setup sh with our username and our group, which is in our case pi. That way the command should be accessible over the whole systemd, and we can also export this part using the systemctl command. and we see that the authentication is complete. So now when we reboot our Raspberry, this command will be still accessible. Another command which we want to also do is we can start telemetry for a specific node which is not as of now of relevance because we don't have any node running yet, but we can just be ready for the future, so we can start the telemetry, and for any possible system which we will start, the telemetry is basically running and collecting the data, which I think is nice for the team so they can later on work on it and improve the performance of the system. In case you decide in the future to disable the telemetry, you can just run disable option. That way it's no longer running and it's not collecting any additional data. In case you want to enable it again, you can just enable it again, and that way it's running. And now we can also start our first node. So how do we do it? So we can basically start a command called the globe, which is in this directory. So this is basically this command. So we execute it, and later on we provide the commands to start a node inside of this directory, starting with data. And now we see that an Algorand node has been successfully started, and for us it's also important now to see and verify that the node is running. So we can do pgrep on the running processes and look for Algorand. So, and we see that this node has the process ID of 13886, and in case we want to stop it, we can do the same. So instead of doing the start, we can run stop command, and this way it's stopped. But before we stop it, we also want to have a look on the current status. So basically we again use the goal information. We want to run audit on the node, and we want to check the status of the data setup. And here we see that the last committed block is 80, so it means it's of course totally off. It's basically really much behind the setup, and it means as if you remember the graphic, now we are basically in the private network that we are connected, but we are actually not really part of the overall group, and we are connected to the mainnet, meaning that we are basically, in case you would synchronize and connect the node, they would be part of the mainnet, meaning that we would basically be part of the big deal Algorand network, which is not what we want in this tutorial, and therefore we want to now change to the testnet configuration. And how do we change to the testnet configuration? So again, within our current directory, we basically see that we have all the application, and we were starting before that the node within the data. So we will follow this pattern, and we will create a new directory within this called testnet data. And what we're gonna do now, we will copy from the Genesis files. Maybe we can firstly check what do we have in the Genesis files. So here you can see that there are important information for the testnet, mainnet, and devnet, and betanet, and so on. And what we want to do, we want to copy the configuration file from the Genesis files. If you want to do it this way, we have to go like this, and we want to go to the testnet, of course, and we want to copy the Genesis JSON to the current file which we have generated, which is called testnet data, and we want to copy it there. And when we go to testnet data, we want to have a look on this Genesis JSON, how it looks. So it's basically providing the information which are relevant for the bootstrapping of the testnet data, where we, for example, important for the part making the relation. So now basically we will start a non-relay node, but of course in order to be able to communicate with the address, we want to connect to some relay nodes, and basically in this Genesis we also see some information about these relay nodes. Great, so now when we have our directory ready for setting up the testnet node, what we can always try, we can just basically follow the same syntax as before, where we want to start a node, and this time we are referring to the testnet data directory which we have created before. We see it was successfully started, and we want to now check the status of this node. and we see that it's pointed to the testnet, and it's pointing to the last consensus protocol, which is basically the current part of the configuration in case you want to go to check at the GitHub. So this is already a good setup, but now it's important that we basically started our node in a private network, and it's much more behind the latest changes. So what we need to do, we want to catch up on the latest block. And how do we do it? So for that, there are commands I will show you, where the first important command is this, again, bget, which is basically calling the giving page from which we get the information. So we want to go to the AWS server and download the latest checkpoint, which is basically telling us the information about the last block on the network. And now we download it, we can also have a look on this look, and we see that this is basically the information about the block, which is already the latest one. And we want to fast catch up to this latest point. And the way we do it, so we can set up a catch up point as a variable. So this is basically this part. So now we have it stored inside of this catch up variable. This is exactly corresponding to the stuff we defined before. And we again want to use the goal command to run the node catch up using this catch up point. And we want to run it on our testnet data node. We see that it's changing. And how do we verify that this is running? Is basically here you see before that it was 205, now it's 735, and we also see how is it changing. And especially important for us are those catch point accounts processed and catch point total accounts, and we will see that if we would keep checking that this value is always increasing, we can try to keep an eye on it and see how this is changing. And in order to see that it's changing, we would have to add a new command or parameter, sorry, -w with a time of, let's say, 1000, meaning that we'll be checking every second about an update, because this is in milliseconds. So now every second we see that this value is changing, and basically once this is completed, it means that the current node already caught up on all of the previous blocks, and in case we would do or issue any transaction, basically we would be on the latest phase, and we should see it really quick, because as we know, Algorand operates really fast, and the results of the transaction should be visible within, let's say, 5 seconds. So this is basically the time since the block is proposed and is later on run the consensus mechanism on it, and it's later on put also on the blockchain, and then later on it also has to be, of course, distributed among all of the other nodes. So we can keep this one running. It will take some time, of course, because still we have to catch up on a lot of blocks which are ahead of our current status, but it's still rather quick, and we can proceed with other configurations. And with that is our first part of the tutorial over.